You're listening to the HyDeploy podcast, a conversation about introducing hydrogen to the UK's gas network. Hydrogen is increasingly being recognised as a viable green fuel for homes and industry in a net zero future. Let's find out why. Well, welcome along everybody to this first podcast, which is all about that wonderful chemical element hydrogen, and specifically a project known as HyDeploy. Now, those in the know are hailing HyDeploy as an important step towards all of us potentially frying our eggs and heating our homes on 100% hydrogen in the not too distant future. So with us, we have three experts in this field, and I'm going to go round our virtual table and ask each of them to introduce themselves. So, Angela, shall we start with you? Can you tell us who you are and a brief bit about your organisation, please?
Yeah, so I'm Angie Needle. I'm the Strategy Director at Cadent. And I'm responsible for planning Cadent's transition towards net zero. So how do we transition from being a fossil fuel delivery company to one that delivers green gases like hydrogen and biomethane? And Cadent, for those who don't know, is a gas distribution company. We deliver gas to 11 million homes and businesses in the UK. And we, those yellow pipes that you see coiled up and digging up the roads, that is us. And so we do that safely 24/7.
Ah, yes, the famous yellow pipes. And Tim, I think you know something about yellow pipes as well, don't you? Perhaps you can just give us your introduction.
Yeah, hi, I'm Tim Harwood. I'm Head of Programme Management and H21 Project Director at Northern Gas Networks. So as Angie says, I work for a gas distribution network in the north of England, looking after the supply of gas to about 2.7 million customers. And I also head up some of the hydrogen projects that we're doing H21, and also the HyDeploy 2 trial that we'll come on to talk about at Winlaton. So I've been in the gas industry for a few years now. I started in 1980. I know I don't look it, but I've done nearly 40 years. And so, yeah, this is a great way for me actually to sort of finish off my career getting involved in hydrogen, and it's really exciting times.
40 years, it's impossible to believe looking at that youthful face, Tim. And Chris, tell us something about yourself and your organisation, please.
Brilliant, thanks, Nick. Yeah, so my name's Chris Manson-Witton. I'm one of the directors at a company called Progressive Energy. So our mission is to try and take lots of carbon dioxide out of our energy system. That's always been our mission. In fact, we started looking and working on hydrogen over 20 years ago. And at the moment, we're working with both NGN and with Cadent on the HyDeploy project, which we'll talk about today. But we're also working with Cadent on HyNet, along with some other partners as well, which is how in the Northwest we can actually allow hydrogen to make a difference to the way we heat our homes, to the way we generate power when the wind isn't blowing, and how our big industry can also find ways of saving carbon too.
Okay, Chris, thanks very much. That's fascinating stuff. So, everybody, we're talking about hydrogen today and why many people are hailing hydrogen as an essential part of the mix, really, as we head towards a zero carbon economy. So, first of all, Angela, perhaps you could set the scene and tell us, first of all, well, what's so great about hydrogen?
Well, it's really becoming a thing, isn't it? So it's been in the news a lot over the last few years. So when we only had to achieve 80% carbon emissions reductions by 2050, that 20% that was left over, that was everybody else's problem, right? That was the bit that was hard to solve. And what hydrogen does is it solves all those bits. So it provides an energy source for industrial use, for decarbonising heat in buildings, for hard to decarbonise transport, heavy goods and shipping and things like that. And hydrogen's really versatile because you have to make it, but it's a great store of energy. You can transport it as a gas, you can compress it, you can store it, you can save it for a rainy day. And don't forget, this country has massive seasonal energy demand. So many of the listeners won't know that the current energy system in the UK is pretty much driven by natural gas. So the country uses 900 terawatt hours of natural gas and only 300 terawatt hours of electricity. So our gas system today does all the hard work and all the heavy lifting most of the time for our energy system. And we've got to turn that on its head completely. And hydrogen is the way that we're going to do that.
One of the interesting things about hydrogen, or one of the really valuable things, I suppose, as we look towards 2050 and finding an affordable way to get to net zero, is that potentially we can transport hydrogen through the existing gas pipe, so we don't need to, completely reimagine the network. Tim, perhaps you could just give us a few thoughts on that.
Yeah, no problem. I mean, obviously, if we repurpose the existing gas distribution networks to carry, whether it's a blend of hydrogen to start and then 100%, we're causing much less disruption to the public. We've spent billions and billions of pounds over the years building up a huge, hundreds of thousands of kilometres of underground pipes that people can sometimes see as out in the street. We're still doing it. We're still replacing metallic pipes with the yellow plastic, as Angie says, and we'll continue doing that for at least another 10 years, if not more. But we do have a fantastic asset that's already available in the ground. And to build that from scratch, as I said, would cost tens and tens of billions of pounds and probably decades as well. So we need to repurpose that. We are the people who really can provide a solution to customers for their decarbonisation at the lowest disruption to them.
Talking about customers, what's the initial reaction from customers when you broach the topic of hydrogen and tell them that there's going to be something, a different chemical flowing through their pipes? Do they react with alarm or curiosity, or what's the word on the street?
So I guess at Keele University, where we're doing our first trial, where we're doing that, we had the opportunity of working with some really good social science teams there working in the university, and so they took this really seriously and helped us to engage with our customers out there. And so we got a range of reactions. I mean, I think it is fair to say that initially there may have been some anxiety from some people because it's something new. I mean, whenever anything new happens, and particularly, I guess when you feel it's happening to your home, you feel sort of that bit more engaged with it. It's something that you're concerned about. But actually, when people found out more information, it was finding more information generally gave them the reassurance. And I'm sure we'll come on to talk about it. But we have, in the UK, we have the Health and Safety Executive who are there to look out for all of us to make sure that things are done safely. And I think when our customers found out how seriously the Health and Safety Executive took the trial that we were doing and needed to make sure it was all safe, that gave them a huge amount of reassurance. And then sort of going to the end of the trial, actually the comments we've got were things like, I'm contributing by doing nothing. Where else do you get to do that? So these were customers who just kept on using their boiler, they've cooked their eggs in the morning or whatever, no change to their routine, and yet some of that energy they were getting was from low carbon hydrogen, so they were making a difference.
I have to say that's my kind of saving the planet, really, just sitting there watching Netflix and knowing that you're making a difference. But we'll come on to talk about all of that in a bit more detail when we get into the nitty-gritty of what HyDeploy is and the various phases of the trial. But before we even do that, I just wanted to touch on what we've alluded to already, which is this concept of blending and what that means, because when I think of blending, I suppose I think of whiskey first and foremost. In fact, I don't know whether it's time for a drink yet. Probably not. But Chris, staying with you, is blending hydrogen? Is it anything like blending whiskey?
Well, I guess it is really. I mean, you are literally taking the natural gas that, as Tim and Angie have said, just serves us so well. That network of that we have and the gas that we have, it works. You flick your boiler on and it starts getting warm and your house warms up nice and quickly. That's the gas we've got coming in, and literally we do just mix into that some hydrogen. So we're in a kind of ratio of one unit, one lot of hydrogen to 4 lots of natural gas. So that gives us a 20% mix. So yeah, I don't know whether it's your whiskey or whether it's your lime cordial with your fizzy water. I'm not sure which, but it's.
I think we should use whiskey.
Oh, okay.
Sorry. I think we should stay with the whiskey analogy. It's much better.
So you've got your ratio of 4-1 that you've put together. So you've got a 20% mix, like you do with your whiskey. And then we make sure that's properly mixed, and then we put it into the network. And then we've done a lot of work to make sure what happens when it gets into the network, and we can talk about that.
And why 20%? Is that recognised as the sort of upper limit that you can put in without having to intervene to change boilers and alter the network substantially and so on?
Yeah, it is for the moment for trials. I think since the 1990s, appliances in the UK have been certified to be able to run on up to 23% hydrogen. And engineers being engineers, we like to have a little bit of a safety margin built in. So we thought 20% was a good point, and it's probably the maximum amount of decarbonisation that we can get. So it's the best bang for your buck, really, I suppose, without having to do any disruption and change people's appliances.
It's worth saying as well, Tim, isn't it? The gas network has seen hydrogen before. So back in the days of Towns Gas. Hydrogen was about 40 or 50% in many cases. So blending 20% in, but obviously this is low carbon hydrogen, so it's not quite the same. But it's not really a new thing. But what it does mean for customers is they can immediately decarbonise their gas consumption. It's just got less carbon emissions, and when they're burning hydrogen in their home, it creates just water. So it's a brilliant solution.
And before we just move away from this, I'm interested as well to get your thoughts about blending in terms of the longer term strategy. Do we see blending as an end in itself? In other words, if you could put 20% hydrogen across the UK, or is this really more a stepping stone to 100% hydrogen? Is this designed to sort of kickstart the market and kickstart consumer interest?
I think it's both, really. I think, blending was the quickest way that we could get hydrogen on the agenda without having to make any major changes. And, obviously we don't want to cause disruption. We want to take the path of least resistance. And to get hydrogen out there to stimulate production and to do trials of how we'd actually do it going forward, blending was obviously the quickest and easiest way of being able to do that. We would like to convert the network to 100% hydrogen, and obviously that's when you will get a full decarbonisation. But in the intervening time, there's definitely a place in the UK economy for sort of quite large-scale hydrogen blending. It will get people used to it as well. It gets hydrogen out there and takes away the mystery. As Angie said, I sometimes put a graph up that shows the start of the gas industry in the early 1800s up until now, and it's only right at the very end where hydrogen drops away to nothing in the 70s up until now, and now it's going to pick back up again and start becoming a thing. So in the history of the gas industry, hydrogen has played a major part for hundreds of years, and we just need people to get used to it again, and that's what blending will be able to do.
And I suppose blending in its own right can deliver significant carbon savings.
Yeah, so I mean, we talk about it in sort of millions of tonnes is how we tend to talk about carbon. So we would say that's 6 million tonnes if we rolled it out in the UK. But what does that mean to us? And I think to us in our daily life, that's the equivalent of taking around 2.5 million cars off the road every year. Which is a significant change that we can make. And again, back to the same point, but without actually disrupting our customers in doing it.
Can I add something else? So the thing about blending, and it's a journey towards 100% hydrogen, is that hydrogen's got a bit of a chicken and egg situation at the moment, in that we need quite a lot of it. We need 300-400 terawatt hours of hydrogen, and we don't really make any today. And one of the reasons why we don't make any is that there's nowhere to put it. There's no demand centre for it. And so whilst we're creating demand centres in the industrial clusters where there's a definite need to fuel switch to hydrogen, you could make a huge demand centre which gives certainty for people who want to make hydrogen that it's got a market for it by enabling blending to happen. So whilst this is important for decarbonising people's homes and heating, absolutely, the biggest thing actually is that it stimulates the economy to get going. And don't forget, the hydrogen economy for the UK is going to be worth a significant amount of money, jobs, skills, exportable assets for the UK, as well as achieving our net zero targets. So blending actually does lots of things that that we wouldn't have otherwise. It's really important.
Well, I think that brings us on neatly to talk more about the specifics of HyDeploy, which I suppose this project is kind of the pin-up for blending, at least here in the UK. Now, HyDeploy is a project in several parts, several phases. Chris, perhaps you could kick us off with a quick overview of what it is, and maybe start us off by talking about phase one of this project, which is well advanced now already, isn't it?
Yeah, sure, I will do, yeah. So the objective of HyDeploy at the end of it is that somebody could just turn up who's got a source of hydrogen, and they can just say to one, Cadent or NGN or one of the gas companies, I'd like to connect this to your network, and I'd like to make low carbon hydrogen and deliver it to customers. And the idea is by the end of the project, we'll have addressed all of the safety and practical issues that we need to evidence and make sure we get right so that that can happen. And as you say, Tim, it comes in a number of phases. The first phase is at Keele University. So we chose Keele University because it's actually the biggest campus university in the UK. And they run their own energy systems. They've got their own electricity network, their own gas network. And so they're like a small town in microcosm. So on the part of the network that we're working on, there are 100 domestic properties, but there are over 30 bigger commercial properties. There's the cafeteria where you get your food, there's a row of shops, there's the lecture halls, there's things like that. So in one little area, we managed to capture all those different type of users of our gas network. But importantly, they run and operate that gas network. So it's really suitable for running a kind of trial like this. And then the trial itself at Keele comes in 3 phases. So the first one I talked about is that it's really important that what we do is safe. And to run the gas network, there are some regulations that stipulate, amongst other things, how much hydrogen can be in the gas network. And that regulation at the moment is a tiny, tiny amount. It's 0.1% can be hydrogen. But what the Health and Safety Executive are able to do is there's a system by which they can take something like a constraint on hydrogen and issue what's called an exemption. So they can take an exemption to that part of the regulations that says, if you can prove to us that it is just as safe to run on this changed specification, this extra hydrogen, than it is just to run as normal, then we can say, under certain conditions, you can then have the permission to operate at that higher level. And if you do, then we'll treat it as just normal gas. So we had to make that safety case and present it to the Health and Safety Executive. Now that was like doing, I know Angie's done a PhD, I've done a PhD. It was certainly a good number of PhDs worth of information across lots of organisations. So we, obviously, NGN and Cadent, ourselves, Keele University, and importantly, the Health and Safety Science Division. There are some fantastic laboratories up in Buxton. They're a bit like something out of James Bond. They do all sorts of exciting things up there. So we work with them, and then we also work with ITM, who are the provider of the source of hydrogen that we've got. And between all of us, we then pulled together over about a year and a half that evidence to present to the Health and Safety Executive. But having gone through all of that process, they said, for what you're doing at Keele University, we can see that it is as safe as it is to run on natural gas. And so they gave us that exemption, which effectively allowed us to start blending. So having got the permission, we then actually built the equipment, and building that equipment involved building a machine to produce hydrogen, the electrolyser, and the equipment to blend it into the network. And we actually did go into the vast majority of the people's homes. We made sure their equipment they already had was safe, just safe on natural gas, made sure that was okay. And we offered to service that equipment during the course of the trial and things like that. So the customers had a benefit. And then having done that, we then started blending hydrogen into the network and nobody noticed anything. So we considered that quite successful, really. So genuinely, people have found that their day-to-day lives just carried on. We've obviously taken lots of measurements. So we take measurements out on the network and make sure that the hydrogen is the same composition at the end of the network as it is at the beginning and that we haven't lost any. And we've also got a set of boilers. So all the big boiler manufacturers in the UK, Baxi, Worcester Bosch, Valent, Ideal, they've got a lovely set of boilers we've set up in a test facility there, 2 of each, one running on natural gas, one running on the blend. And we've run those really hard over the last year. So almost equivalent of 10, 15 years worth of operation, so that they can understand any longer term implications of what we're doing. But the great thing is they don't know which one of the boilers is on natural gas and which one's on a blend. So we're just about to stop blending. We're coming to the end of the trial. When we've finished, we'll take those boilers off the walls, give them back to the those manufacturers, and they'll strip them down and they'll make sure that I understand if there are any differences, if they can spot any differences, so that then they've stood behind their boilers during the trial at Keele, but they want to know that if we roll this out across the UK, their boilers are going to be just as good in 15 years' time on a blend as they are today.
That's fascinating. It sounds a bit like the Pepsi challenge, if you're old enough to remember that, where you don't know whether you're tasting Coke or Pepsi, and that presumably that's the same sort of challenge that the boiler manufacturers will be going through when you present them with these boilers that have been run ragged with the hydrogen blend and the natural gas.
Yeah. That's exactly how we want it to be.
I love it. And Angela, you've done some consumer research as well, I think, at Keele, haven't you, just to sort of gauge, public reactions to this. And I think Chris alluded to the fact that really everybody's pretty much on board. What have people been saying?
So I think, as was mentioned earlier, the issue is really about education. So it goes through you're planning on doing what to my gas supply, to, actually, well, that sounds fine. So it's moving from the, experience of it being something new, and, hydrogen does tend to get linked to some unsavoury historical events. So, let's talk about those. Let's talk about the reality of it. And actually, let's talk about the fact that we transport a combustible gas through the gas pipe all the time anyway. Once customers got comfortable with that fact, and NGN and Tim will talk about some of their customer research that they've done as well, but they trust us. We are the service provider, right? Customers don't really want to have to worry about whether it's safe or not, because that's our job. And so once you've got them over the education hurdle, which is explaining how it works and what it is, and the fact that it's actually better for the environment and for them from a carbon monoxide point of view, they want to know why they can't have it straight away. So there tends to be this, when you think about how you're going to roll this out nationally, not only do customers not really know that their gas boiler is doing harm to the environment, but they definitely need, to get over that hurdle of just information and being reassured of what's coming and when. So, it's been very, very positive, and we've probably got some hydrogen advocates now at the Keele domestic properties that we didn't have previously.
Fantastic. That's great to hear. And Tim, so phase 2 of this project is going to see this blend of hydrogen out in residential streets. You're leaving the cosy confines of the Keele University campus. Just give us an overview of phase 2. Where's it going to happen? When is it going to happen? Yeah, tell us the story.
Yeah, okay. I mean, it's a natural progression from doing sort of closed trials within a more secure environment to take them out into the public domain and test them out there with the general public, and so we're doing that under HyDeploy 2. So we've chosen a place called Winlaton, which is a village which is just north of Gateshead in the northeast of England. The main reason we chose that is it's quite near a site that we used to use for research purposes called Low Thornley, which we've sort of brought back out of retirement, if you like, and it's going to become a sort of centre of excellence for hydrogen. There's a number of different projects going on that site at the moment, and that is where the hydrogen will be injected into the network, and it will flow a very short distance down the road to the village of Winlaton. So it's 670 properties. It's part of a larger village, and so what we did is we isolated the section that we wanted to work on from the existing gas supply. We put in a number of sectorisation valves, as we call them, did some tests to make sure that we'd isolated completely from the gas network and nothing was going to sort of get back and intermingle in either direction. Visited all the properties, made sure, as Chris says, that we'd serviced all the appliances. There were nothing too untoward. Any appliances that we felt were sort of more worthy of being in the Science Museum, we replaced with new ones, and just made people feel a bit more comfortable about it. We didn't really find too many issues, to be fair. And so we started constructing the actual injection point at the site at Low Thornley. We've been slightly delayed by a small little thing called COVID-19 that got in the way, unfortunately, but we're well on the way with the construction now. And we should be able to be blending by mid to late April. So just around the corner, we're actually going to be doing the first sort of blending trial in the UK of people's homes, and we're really looking forward to it, and I'm really excited by it.
It is extremely exciting. And the residents themselves, how are they feeling about it?
Yeah, they've been really supportive. You know, we've done lots of drop-ins, sessions, visited every property, as we've said, done lots of sort of social media and things. Out of the 670, you know, there was only a handful really who sort of at the start sort of had objections. They've subsequently come round to understanding what we're trying to achieve and do. And as both Chris and Angie have said earlier, you know, the public really trust what gas networks do. Their response to our sort of questions and research is, well, we expect you to do the right thing, and you wouldn't put something into our houses that would put us at danger. So we trust what you do. And if you think about that, it's absolutely a brilliant testament to sort of how safe the gas industry has been over the years and how resilient it's been. And one of the things we really want to do is to make sure that we keep that going and that we maintain that sort of trust and that level of confidence that they have in us. But when you talk to the public in Winlaton about sort of the trial and how things are going and what could potentially happen after the trial, they're very excited about being part of something that is a sort of a UK first and almost potentially a world first in the way that it's done and the percentage of blending that we're putting into the system. And they don't really want to go back. You almost then get the public pushing the networks forward as well. And that is what we really need, you know. The government needs to be involved and our regulators need to be involved to a great degree. We have to have the same exemptions and all the same safety related things that Chris has mentioned, which we're working on at the moment. The network at Winlaton is a mixed material, so it's not all the brand new sort of yellow plastic. There is some metallic in there as well. And we just need to prove that we can do it safely. But at the end of the day, I think having the public perceptions of hydrogen and the public behind us is going to be a really big boost in trying to get further projects put on the board and get funding, which we really need to do to drive it forward. So yeah, it's just a fantastic opportunity really for everyone to show that we can do it.
Sounds great. And the public reaction sounds marvellous, really. The fact that you're taking people with you and creating these advocates. So once they've got this 20% blend flowing through the pipes, how long will they have it for? How long is the trial going to last?
The trial's going to last approximately 10 months. So it's probably going to be finishing sort of around this time next year. Which is great. You know, that will allow us to prove that we can do it, do all sorts of testing of things, work out sort of how the supply chains worked and just the whole thing. We've trained a lot of emergency engineers up. If you ring the emergency number, you'll get the same standard of service that you'd get if you rang up to do a gas escape. everything's going to be the same, but we do need to practice over a few months. We need to do a summer and a winter, which is really why we've done a 10-month trial, so you can get all the seasons, all the gas demands, and everything that you normally would have as far as operations and maintenance are concerned. So by this time next year, potentially, we'll have completed a successful project, and we'll be looking forward to doing wider blending trials across the UK, because we should have hopefully proved that we can do it. And there really aren't any barriers then, other than the economics of people wanting to produce hydrogen and put it in our system.
And Angela, there is a phase 3 coming down the pipeline sometime in the future, but it's a bit more theoretical perhaps at this stage. Perhaps you could just give us a flavour of what that third and final phase of HyDeploy is going to be all about.
Well, yeah, and the bits of HyDeploy so far have been very much focused on people's homes and the appliances in people's homes. Now we know beyond that, and when you look into towns and cities, there's a much more complicated landscape of appliances and assets that use natural gas today, catering equipment, and so the next phase of the trial is going to look at these commercial appliances. So how can we make sure that a hydrogen blend is acceptable to the whole range of commercial appliances that are available? If it could be Bunsen burners in laboratories, and everything in between, we need to make sure that we're not putting any inconsistencies or any unintended consequences into the energy system. Now, at some point, we're going to have to address all these when we move to 100% hydrogen, but it really does help us understand where the uses of hydrogen are going to be in the future, the kinds of things and assets that they're going to see. So it's quite an important last phase, which is in the pipeline, no pun intended.
And we're doing some really exciting work with some big industrials at the moment as well. So just after Easter this year, we're going to be putting a blend of hydrogen into Pilkington Glass, so big UK glass manufacturer. So they've got these huge, great big furnaces that melt down the glass and then make flake glass for the windows that we all use. So we're going to be running a blend of hydrogen just after Easter to trial that in their facility. In fact, we'll also be operating, not as part of this programme, but actually looking at 100% hydrogen as well, because as Tim and Angie have said, it's about a journey too. It's not just what can we do now, it's what can we do in the future. And we're also working with Unilever. So they make lots of the bathroom products and things and the kitchen products that we have around in our homes. They've got some very big steam boilers, huge, great big ones, sort of 100 times bigger than the domestic boiler, or even 1,000 times bigger. So big boilers. And again, we're going to be running a blend of hydrogen into those boilers too, and making sure they run just like they do today. And of course, big business like that really needs to be confident that it's got to work as well, because their processes can't suddenly stop for a moment while it gets used to what's going on. They've got to be able to run seamlessly, and we'll be making sure of that too. So as Angie says, that next phase is broadening the canvas to not just domestic properties, but actually how can we put a blend into our whole natural gas system.
Wow. It's exciting stuff. There's lots happening. To wrap up the conversation, really, I'm quite interested to get your predictions of where you see the hydrogen landscape in the next 5 years, the next 10 years, and perhaps we could go around the table and get your Mystic Meg predictions. Angela, would you like to start?
Yeah, so in 5 years from now, we'll have a hydrogen strategy for the UK, which my preference is that it's globally ambitious. And puts the UK on the map. That may be slightly more wishful thinking, but we're working on it. 5 years we'll have some of the big industrial clusters making hydrogen at scale. We will be blending hydrogen surplus to the needs of industry into the gas grids nearby. We'll have successful 100% hydrogen pilots in towns, in villages. And we've got some in the pipeline. I keep saying pipeline, I can't help it. And then, in 10 years' time, all being well, it will just start to scale, and we'll start to see, regional conversion plans being put in place to convert to 100% hydrogen. And then the reason why that's got to happen in the next 10 years is that without it, we won't get to net zero by 2050, and it is going to take some time to have enough hydrogen to do, a piece-by-piece conversion of the UK. So we need to plan that really carefully. And we also need to do it in tandem with other parts of the country which are planning to decarbonise in different ways. So there'll be some buildings that get heat pumps and some that get hydrogen. That it's got to be carefully stitched together.
Tim, has Angela nailed it there, or is there anything else you would add to that picture?
No, it's pretty much that's the sort of direction that we're going. I think I'd add in a couple of things. People might be getting sick of people like myself and Angie and others saying that the government needs to make a decision on hydrogen-ready appliances immediately, not before 2025. There's absolutely no reason why by the end of this year we can't start manufacturing hydrogen-ready appliances. They're all pretty much done and finished as part of the Hy-for-Heat project. We're going to be installing some of them in our hydrogen house at Lowthornley and testing them, doing the runtime that they need to get certified. And then it's up to the government to announce that they're going to back hydrogen-ready appliances so they can change their production lines and start making them. And the reason that's so important is because a hydrogen-ready appliance can be bought by a customer and put into a house to run on natural gas. And then it can be converted at a later stage really simply over to hydrogen, rather than having to rip that out of the wall and put a brand new appliance in. And it's so much less disruption and time and cost. Very similar to the digital TV switchover, where they started producing the TVs 10 years before they did the switchover. And then when the switchover actually came, nobody really noticed the difference. Everybody already had all the kit in the house. That's what we want to do with the appliances. So that's really, really important. And I think the second point is just about the level of ambition. So I'd agree with everything that Angie says, but the government's 10-point plan at the moment says we'll have a hydrogen town by the end of the decade. And by town, they mean 10 to 15,000 homes. We should be saying that we can do a city by the end of the decade. And we need to be more ambitious, or at least multiple towns. So we're working on schemes where we want to try and make that possible, pull together the whole supply chain. And, it's all about economics and production and getting the cost of producing a kilogram of hydrogen down to a level where it's acceptable to society. And the longer we sort of dilly-dally and not have policy decisions, the longer we're going to leave that point in the future. And as Angie says, we're already running out of time. 2050 might seem a long way away, but actually, we are really, really getting behind the 8 ball here, and we really need to be a lot more ambitious. I think the networks are ambitious and they're trying to push the boundaries, and we want to try and encourage the regulators and the government to come with us.
Chris, any final thoughts?
I think Tim and Angie have both covered it, but why don't I give you an example of what it might be? So we hope there will be clusters of hydrogen industry working across the country to help get our homes more environmentally friendly. It can help our big business not just save carbon, but actually be really competitive in a global world where carbon is important. It allows us to, offshore wind is fantastic. It gives us lots of low carbon electricity, but sometimes the wind doesn't blow. So you need something to fill in the gaps, and hydrogen is really good at doing that. And transport as well. So we all jump in, we jump in our cars today. Increasingly people are getting into EV vehicles, but actually those bigger vehicles, buses, heavy duty trucks, and even trains, it's not always easy to put an electric solution there. And actually hydrogen could be that. So we could be getting on a bus as well. So we'll look back and we'll be really surprised that hydrogen wasn't part of the way that energy was delivered to us. So that's what we're looking forward to, and that's what hydrogen can offer for us.
Thanks for listening. HyDeploy is a partnership between Northern Gas Networks, Cadent Gas, Progressive Energy, Keele University, ITM Power and HSE Bespoke Research and Consultancy. For more information, head over to hydeploy.co.uk.